Hi, good morning, everyone. Uh, this is Krishnan Kannan, part of Amazon Internet Services. I, along with my colleague Abhishek Manti, will be presenting to you on the topic cloud economics, lowering the cost of running databases on AWS Cloud. In the first section, I'll be taking you through what are the different strategies that organizations can adopt from comparing the cost of running on the workloads on the on-premises or co-location versus moving to cloud. And on the second half, my colleague Abhishek will be taking you through how some of the specifics around the databases and how one can end up optimizing the cost of running the database workloads. So let's get going in the interest of time. Before I move to the topic of cloud economics specific, I just wanted to just give you you know in terms of how AWS compares with other cloud providers. So on basis of these 7 parameters, we compare ourselves with others. The first includes security, whether you're running web workloads or an application or a database workload. Security is one of the important aspects that every organization is looking for. And what we provide in security is a fine-grained control. Apart from that, we also have the service breadth and depth, which is 100 plus services to support any cloud workload, experience of managing 1 million plus customers over a period of last 12 years, global footprint in terms of availability of regions and data centers in the availability zones, uh, the new age technologies like machine learning or AI, and how quickly we have integrated that with the solutions or the platform is also something which many of the organizations are able to differentiate us. The last two being the ecosystem of partners that we have built in over a period of last 12 years, which includes aspect like marketplace as well as the partners to support organization or help them migrate their workloads to cloud. And due to all these efforts, the independent analysts like Gartner as well as other analysts have also recognized AWS as the leader uh, in the entire infrastructure, cloud infrastructure space. This is the latest Gartner Magic Quadrant where AWS has been positioned as a leader. And if you see the comparison around other cloud providers also. So with this kind of background, let's get into the topic of the cloud economics. What does cloud economics exactly mean? Uh, in AWS, the study of the cloud economics or aspect of cloud economics has two parts to it. One is the business value on the TCO, which most of the customers would do before they migrate to cloud. Yeah. So sorry for this. So we're talking about the business value and the TCO, where customers do the analysis of how the comparison looks from AWS perspective before they move on to cloud. The second aspect is very important. How do you optimize the cost post you migrate on AWS cloud, and what are the opportunities to optimize? Whether it is running your database environment, whether you're running an application environment on the infrastructure, how do you end up optimizing the cost? The whole aspect of cost reduction as well as optimization from an infrastructure standpoint is what the practice of cloud economics does in AWS. If you really look at the way in which the whole aspect of cloud computing evolved, it was similar to how the entire aspect of Power Grid evolved, right? There was a time where most of the organizations built their own power infrastructure in terms of building their own power plant because they did not have infrastructure or they did not have a mechanism to draw power. And then the concept of the power grid came in where you were able to tap into the grid infrastructure, and a lot of those and people stopped building some of the infrastructure required to tap power. Similarly, when it came to the IT investments, many organizations went ahead and built their own data centers, which required large upfront capital investment. Organizations were responsible for upgrades, but the cloud technology changed the entire aspect of how you, you know, build the certain functionalities and how you only pay for what you use, right? Let's look at why the economics of the cloud becomes very compelling when organizations, you know, if you compare with the traditional infrastructure. In the traditional infrastructure, which requires large capital expenditure, the demand could be something very similar to what has been depicted as on the red color, right? So the gap that you see between what you have invested and what is the demand is what is called as an opportunity cost, which means you had an opportunity to deploy an infrastructure at a lower cost, but because it's very difficult to guess capacity in a traditional environment, that gap that we are talking is an opportunity cost. But whenever there is an excess demand and your existing infrastructure is not able to meet, that's called as a lost opportunity. And that's what the lost opportunity gap shows. But assuming the yellow line, which is being shown in this graph, is automated virtualization, or for a moment, think about it, Amazon Cloud. Uh, there's no lost opportunity because you're able to meet a lower demand based on a feature called auto scaling, and you're also able to ensure there is no lost opportunity whenever there is a spike in the your incoming traffic, which is what the beauty of the cloud, especially around AWS cloud, is all about in terms of the ability to scale up and scale down. Let's also look at some of the key benefit categories with regard to the AWS cloud, which is where the entire economics of the cloud will revolve. Many organizations have given us a feedback that apart from the costs, which is anyway on the operational cost, one of the unique feature of cloud, they also see benefit around business agility and operational resilience, cost avoidance, and workforce productivity. And if you really look at the first four aspects, this has huge role to play whether you are running your application workload or a database workload. And my colleague would demonstrate certain aspects of all these when he talks about how you can optimize the costs around databases. Now, let's look at each and every aspect of how the entire business benefits or the economic benefits of running on cloud means. So if we talk about business agility, the reduced time to market or reduced cost and increased pace of experimentation is what business agility. And if you see, the single biggest reason why enterprises are moving to cloud is to make sure they achieve this business agility compared to what their competitive competition can offer, and how they should ensure that by leveraging technology they're able to move ahead in the competitive landscape. The operational resilience is about how do you build resilience in your network to ensure you're able to reduce your risk profiling or you're able to meet compliance requirements. The third aspect is very important, which is where a lot of financial stakeholders pay very important to the kind of IT infrastructure, which is how the entire technology, by ensuring that you are operationally resilient, can lead to a margin improvement, or at least ensure that there is no reduction in the margin based on unplanned outages that happens, because planned outages is better to manage, and unplanned outages becomes even more difficult to manage. The workforce productivity is how do you improve the developer productivity, or how do you ensure by improving on automation you're able to drive maintenance efficiencies. The fourth point is around the cost avoidance, the whole aspect of how do you avoid certain cost, especially around procurement, especially around the maintenance and other things, and how a technology like cloud, where you do not have the capex element existing at all, how you can ensure that the job of a procurement team, it's easy to ensure that there is a price, the transparency in the prices, as well as uh, based on the fact that the technology, you're relying on a technology rather than on an OEM, becomes a compelling advantage. The last on the operational cost, because there is a unit price of the infrastructure, the ability to match supply and demand, as well as I talked about the transparency of the cost. The transparency of the cost leads to a lean mindset. And that's the whole aspect of the economic benefits of the cloud. So one of the customers, which is GE Oil and Gas, went ahead, and when they moved the workloads on AWS cloud, they were able to quantify those benefits. According to them, that based on the business agility, they were able to deliver business applications 77% faster. On the operational resilience, they were able to reduce the P1, P0 incident cases by 98%. On the cost avoidance, they were able to reduce the overall total cost of ownership by 52%. In terms of workforce productivity, the workforce became more productive because they become operationally resilient, that the workforce are able to develop certain things like automated bots, or they were able to build DevOps practice in their organization for the internal applications. And lastly, they were able to reduce their footprint in terms of one, reduction in the compute asset. Secondly, they were also able to decommission 50 applications which otherwise they would have been running. Let's understand the business value of the AWS. If you recall my earlier slide on the two aspects of cloud economics, one is around the total cost of ownership, but the important thing is the business value of AWS. And all these four aspects of business value, which we call it as part of the cloud value framework, is what we will be talking in next 45 minutes to 1 hour. Me and my colleague Abhishek, when he takes the stock around the running of database environment on cloud. So the whole aspect of cost savings, staff productivity, operational resilience, and business agility. So let's focus a little bit more around the cost savings, which is what we all know as total cost of ownership. And what is total cost of ownership as per in Amazon, and why it is not easy to compare the total cost of ownership if you're especially comparing the traditional data center cost and co-location cost. Before we arrive at that, let's just understand the definition of the total cost of ownership. So the total cost of ownership, the way it's defined in AWS is comparative cost of ownership analysis, both acquisition and operating cost for running an infrastructure environment end to end, whether it is on-premises or co-location versus AWS. It's basically used for comparing the entire infrastructure environment or specific workload on an on-premise or a co-location facility versus AWS, budgeting and building the business case for moving to cloud, and paralleling an existing AWS workload with an on-premises or a co-location setup. There was a study which IDC released, one of the leading analysts, IDC, released last year, and they talked about typical data center utilization. So if you see that idle capacity versus the used IT capacity, the only 45% is the used IT capacity. And you can go through the detailed study in the link that has been shown in the quantifying data center efficiency. But this talks about how massively most of the environments are underutilized, which means there is a huge over provisioning which happens based on the guessing game, and also the earlier slide we saw on the opportunity loss and opportunity cost. Most of the enterprises or organization end up over provisioning the entire data center footprint when they move the workloads on a co-location or on-premises setup. Now, the typical TCO considerations that we likely take are around the four costs, which are fundamentals on the infrastructure, which is the server, storage, network, and IT labor. We would do a detailed comparison on basis of the hardware, which includes the server, rack, chassis, PDUs, and on the software part, the operating system, virtualization, plus maintenance, and the facilities cost. Now we see the facilities cost totally missing in terms of the visibility to the IT team wherever there is a huge on-premises deployment, because the cost is normally managed by the facilities team. Similarly, some of the aspects around storage of how do you make sure that you're able to optimize on the storage based on what you need rather than what you have buy, right? Whether you might be buying in terms of raw storage, but ultimately you might be provisioning a usable storage where there is a huge difference in terms of what you buy and what you end up using it. The fifth item that we see in extras are very, very specific to industries, whether it is you're spending money on compliance, whether there's a cost of capital and all those things. So if we are able to compare on each and every aspect of the total cost of ownership from the server, storage, network, and IT labor, we arrive at a cost which is comparable and then compared to the AWS cost. And that's where we arrive at which would be more economical over a period of 3 years or 5 years, whichever is the comparison. So, but while doing the comparison, some of the questions that we need to ask while exploring the TCO is, how do organizations plan the capacity? How many servers they would have added in the past, and what is the forecast for the next year? Is there an ability for the organization to switch the hardware on and off, especially for the environments which doesn't require continuously running for a certain period of time? And what is the average server utilization, right? It's very important when you run it on cloud that you are able to leverage some of these, because your ability to provision an infrastructure is just matter of minutes. So you don't need to over provision. And that's what exactly my colleague will be talking about, how you can end up optimizing the cost, which also not only brings the ability to run your environment at a much lower cost, also some of the third party license requirements, which also could be reduced, right? In terms of operations, will you be running out of data center capacity, which would be very, very specific in terms of the running the workload, and how you can reduce the entire footprint of the data center by ensuring that when you move to cloud, you don't worry about some of these aspects. And the important aspect of data center is not space, it's power and how do you manage the power, because that is what is going to determine the whole cost of running the data centers. Fourth, if you're already on AWS today and if you're running a certain workload, how do you make sure you're architecturally cost optimized, which means you're able to leverage on certain things on a scalability like auto scaling, or the pricing model like reserved instances, spot instances, as well as ability to turn on and turn off, especially for some of the environments like test, dev, QA, and staging. On production, we do understand the environment needs to be on 24/7. So that's where the aspect of commercial levers that needs to be applied on when you move to AWS cost, which is how do you make sure that you're able to right size your environment, which means how do you exactly match the supply and the demand, right? Right sizing compute and storage, matching supply and demand, which is the elasticity aspect of the cloud. Third is lowering the unit price, which is reserved and spot instances. Now, in terms of the optimization, we have identified additional AWS savings by modeling both optimization and replatforming. Uh, Now, this diagram talks about how when organizations do something called lift and shift, which is, by the way, the most common approach taken by organization to move to cloud, because one, the infrastructure is could be outdated in an organization. Secondly, the organization wants to make sure that the migration time is reduced, so thereby take the entire environment as is running on it to the cloud, and then start doing something called the optimized lift and shift measures, which is what it's shown here in terms of how you can uh, go ahead and do that entire right sizing, elasticity improvement, as well as the storage optimization. Once you reach the optimized lift and shift, then you can always measure and monitor. You can improve on a serverless aspect by making sure you're also able to subscribe to some of those managed services, especially around storage, database. You're able to make sure you can reach a replatformed AWS optimized. And doesn't end here. This also keeps continuing in terms of the right sizing, because it's possible that you might have gone ahead and you know increase your footprint, which means there could be an ability to optimize further. And also AWS provides an opportunity to always migrate to a newer generation instances. So when we do a newer generation instance, when we release, it comes with two benefits. Uh, and these are all what I have been showing is what we have been innovating for last 6 years. So every 18 months, we have been in the past giving an opportunity for customers to move. Now, many customers consider this as some sort of a tech refresh which is happening, which in the traditional world, which is on-premises or co-location, may happen. The organization may have an opportunity to do only every 5 years or 7 years, but in AWS cloud they have been innovating pretty fast. So this comes with two benefits. As I was talking, one, it comes with a reduced price. Secondly, it also comes with a added infrastructure capability as well as ability to on the performance side, it's much better performance than the older generation instance. We work very closely with our OEM partners or the technology partners to bring in these innovation. And if you see the M2, the row number 2, which is M2, it's a memory optimized instance types. The M originally stood for memory. Then we changed it to R series, which is R3 or R4. Stands for RAM. We already have an R5 series, which is not yet available in India region, but it's already available in other locations like US East and Ireland. Similarly, the compute optimized, which is C1, we have got the newer version till C5, so on and so forth. And we keep releasing a lot of newer generations to make sure the customers are able to run as well as they're also able to run efficiently and reduce cost. The number two driver on the entire cloud value framework is around how do you build the developer productivity or the resource efficiencies. Now, if you really look at resource efficiencies, we are not talking about reducing uh, the staff that presently are performing, but how do you build productivity around the existing resources to ensure they are able to innovate and build the next level of infrastructure or the applications rather than uh, maintaining the undifferentiated heavy lifting which can be passed on to AWS. Some of the measures like database administrator, eliminating time spent on DB patches, this can be easily done by moving to managed services like RDS, which is available with AWS. That's one of the things which my colleague will be talking. Uh, some of the examples around how organization did it, Intuit was one of the companies which made sure they're able to, uh, you know, put more focus around their building their platform rather than spending something on data proliferation or lack of standards. Similarly, a pharma company was able to build efficiency around the compute-related functions by ensuring planned DR or a automated DR provisioning, so that they do not they have a better mechanism to fail over. Third is how do you accelerate the entire application deployment, right? Building DevOps as a practice, how you can shorten the amount of time to deploy new applications and features. And one of the great example is from the enterprise segment, which is GE Aviation, which was able to, by putting a DevOps practice, they were able to shorten the deployment cycle time for a new application from 4 days to a matter of hours. Improvement in the speed to market of 240% was another factor which helped them to build more functionality for the customers that was eventually delivered 5x faster than the traditional environment. At this point of time, I want to bring in my colleague Abhishek to talk more about how some of these measures can be put in the database side of things. So I will pass on the mic to Abhishek. Abhishek, over to you.
Hey, thanks, Krish. Hi, everyone. Thank you for joining the webinar on lowering cost of running databases on AWS. Now, in this section, I'm going to primarily talk about how you can optimize your database costs. So I'm going to start with a quick primer around some of the terms that we use when we talk about database costs, more specifically around licensing. We hear about BYOL, which is bring your own license. This is primarily based on license portability rules as set by a particular vendor, be it Microsoft or Oracle. LI, which is license included, is when you procure your license from AWS. That way, the license cost is part of your hourly instance fee. The other thing that comes up is the EC2 tenancy. So by default, when you launch a EC2 instance or a server on us, it runs on shared hardware. But we also have something called dedicated instances and dedicated hosts, right? So dedicated instances is where the underlying physical hardware is not shared with any other AWS account, although it may share hardware with other instances from the same AWS customer account. Dedicated hosts is a physical server with EC2 instance capacity, which is fully dedicated for your use. The way it's different from dedicated instances is it gives you additional visibility and control over how your instances are placed on a physical server, which enables you to use your existing server bound software licenses, like Windows Server operating system license, and also helps you address corporate compliance and regulatory requirements. Understanding what a core means and what a vCPU means is also very important when you are arriving at license costs. Amazon EC2 supports Intel hyperthreading technology, which basically enables multiple threads to run concurrently on a single Intel Xeon CPU core. Now, each EC2 instance, depending upon the instance type, has a default number of CPU cores, and each thread is represented as a virtual CPU on the instance, right? So if we take an example of R4 2x large instance, it comes with 4 CPU cores, each core with 2 hyperthreads. So what you get is 8 vCPUs in total. And it's really important to understand, core and vCPU because most of the licensing terms, revolves around both of these concepts. So if we look at SQL Server license mobility on AWS, you as a customer are responsible for obtaining the licenses required for eligible Microsoft applications using license mobility through software assurance. You can find the details at the URL right at the bottom of the slide. It's a public facing URL. But essentially, the way it works is SQL Server is licensed by vCPU rather than physical core. So, for example, if you're running your SQL Server on an R4 8x large instance, which comes with 32 vCPUs, you would require 32 licenses. But since SQL Server processor licenses come in a pack of 2, with a minimum of 2 per instance, you would require 16 processor license packs. And since as I mentioned it, the minimum is 2 per instance, which is minimum of 4 core license. So if you run your SQL Server on R4 large, which comes with 2 vCPUs, you would still require 4 licenses. The good thing about running SQL Server on AWS is you can benefit from passive failover licenses, which essentially means if you have procured your license with active software assurance and you're running a master-slave SQL Server setup on AWS, where if the master goes down, the passive slave becomes the master, becomes active. You don't need to procure license for the passive server. However, if you don't have software assurance, you will have to buy a separate licenses for both the servers. If we talk about Oracle licenses, most Oracle software licenses are portable to AWS. Uh, includes enterprise license agreement, unlimited license agreement, Oracle Partner Network, and lot others. The link at the bottom of the slide is the public-facing Oracle Cloud Licensing Policy link. There's a PDF with all the details in there. But in a nutshell, if you are running Oracle Database Standard Edition SE1, SE2, you would require 1 license per 4 vCPUs. If you're running Standard Edition or SE1, you can use it for a maximum of 16 vCPUs. If you're using SE2, then you can go for an instance with a maximum of 8 vCPUs. Right. If we talk about Enterprise Edition licenses, you need 1 license per 2 vCPUs with hyperthreading on, which is the default case. If you have disabled hyperthreading, then you need 1 license per vCPU. So if you see, the key factors around licensing, you have to go through the portability clause that the vendor provides, understand the licensing around vCPU and hyperthreading. right? So, having set the context around some of these terms, let's see how you can optimize your database costs, right? More specifically, how you can lower your licensing cost. So, we launched a feature a while back, Amazon EC2 Optimize CPU, which is something that you can really use to bring down your licensing costs. With this feature, you can specify a custom number of eCPUs for new instances while enjoying same memory, storage, and bandwidth for a full-size instance. It also allows you to disable Intel hyperthreading. That's primarily if your applications are single threaded, you're not using multiple threads, so you can disable hyperthreading. So how does that impact your license costs? So take for example R44X large, which comes with 122 GB of memory and 16 vCPUs. Now most customers, when they run their databases, they primarily go for more memory and more I/O than more compute. But when you go for an instance with a lot more memory, invariably, the number of cores or number of vCPUs also goes up, and customer perceive that's something that penalizes them on the licensing cost, right? So, for example, if you're running SQL Server on R44X large, you would require 16 licenses or 8 processor license packs. However, by leveraging optimized CPU feature, you can specify that you just want 8 active vCPUs in R44X large instead of 16. So this way, while your cost of running the instance remains same, but your license cost comes down by 50%, which results in substantial savings. And as your workload, goes up, let's say you go for a bigger server, R48X large, which comes with 244 GB of memory, you don't have to buy extra licenses for the extra 16 vCPUs that you get. You can simply, specify active CPUs 8, so it continues to remain so. So while you're getting more memory, your vCPU that are active remain stagnant, and this results in 75% of your license savings as well, right? So, so how do you use optimized CPU? Right? So R44X large, if we take that example, as I mentioned, you have 16 vCPUs. So if you launch R44X large, with the CPU option parameter, you specify two things: core count and threads per core. Depending upon what instance you are using, you can find the valid number of CPU cores and valid number of threads that you can pass as part of CPU option parameter. I've put a link at the bottom of the slide, and these slides will be available on later on, so you can always refer that. So with that, when we in our example, for example, if we want to run R44X large with 8 active vCPUs, I will simply launch my instance with the CPU option parameter with a core count of 4 and threads per core as 2. So I get 8 effective vCPUs. Or I can simply specify use 8 CPU cores, but I would disable hyperthreading. That way I get 8 vCPUs. So once you launch your instance like this, you can confirm the core count and the threads per core by using AWS EC2 describe instances API call, or you can do it in the traditional manner where you log into your server and run a lscpu command. So on the left hand side, you would see lscpu output when I launched R44X large, the default way without any changes. So if you see, it shows 16 CPUs, 2 threads per core, and 8 cores per socket. While on the right hand side, I have launched R44X large with the CPU options parameter specifying 8 active vCPUs. So when I run lscpu, it shows me there are 8 CPUs, and it shows me details of core and thread count. It's fairly easy to work with. So let me quickly show you a demo of how you would do that. Okay, so what I have here is, a terminal window of my EC2 instance. So I specify the command, which is AWS EC2 run instances, provide the AMI ID there, specify the instance type that I want to use, which is R4 4x large. If you see under my CPU options, I am specifying core count as 4 and threads per core as 2. And I specify the key using which I would log into my instance once it's launched. So when I press enter, give it a moment. As you see here, I have just launched an instance. This is my instance ID. I'll make a note of it, right? And behind the window is my console. Let me just refresh. So as you can see here, there is R4 4x large instance, which is coming up, right? And it has a public IP. So I'm just sticking to the default options. So if I go back to the window and I say, describe instances command, and I specify the instance ID that I had made note of earlier, right? And if you scroll up, you will see under CPU options, the core count and the threads per core that you had passed when you ran it. Or what you can do is log into the server, specify the key that you key name that you used when launching it, which was a B key in my case, and I log in. Right, now once I log in, I open a terminal window. So this is the terminal that has come up. Let me just increase the size. And now when I run LSCPU, so you would notice, the number of active CPUs in my server, right? So fairly straightforward to work with, EC2 optimize CPU feature. So coming back to the presentation. Right. So that was one way in which you can directly bring down your, license costs. Some of the other best practices that you can consider to cut down on your, overall database costs. Often we see that, customers use enterprise edition of databases for all workloads. So what we generally recommend is identify the applications that really need enterprise edition. More importantly, identify the features that are part of enterprise edition that those applications need. If you have applications that are not dependent on some of the enterprise edition features, move them to standard edition. And it's fairly easy to procure standard licenses because you can simply use a license included model that you get from AWS, fairly hassle-free. You don't have to get into any agreements. Other way in which you can, work around some of these features that you get as part of Enterprise Edition, if, for example, if you're using Enterprise Edition from a performance standpoint, is by making small changes in your architecture. For example, adding a caching tier, right? You have AWS Elastic Cache as a service, which supports the two most popular caching protocols, Redis and Memcached. So evaluate if you can add a caching layer in your application, and if you can see a performance improvement there. That way you can optimize on cost. When we talk about SQL Server specifically, there are two key features that are very popular with customers: transparent data encryption and always on availability groups. Evaluate if instead of using TDE, you can use RDS with KMS encryption. Amazon RDS encrypted instances use industry standard AES 256 encryption algorithm to encrypt your data on the server that hosts your RDS instance. Once your data is encrypted, RDS handles authentication of access and decryption of your data transparently with a minimal impact on performance. More importantly, you don't need to modify your database client applications at all to enable encryption. If you're using always on availability groups, evaluate if your workload can work with RDS multi-AZ. So that way, your master can run in one availability zone, slave in the other one, and the failover, if at all, takes anywhere around 60 to 90 seconds. If you're using Oracle RAC, again, we see customers using Oracle RAC for all kinds of workloads. Evaluate whether the workload that you're dealing with really requires RAC, and see if you can use maybe RDS multi-AZ. If you're using Oracle RAC from a performance standpoint, evaluate provisioned IOPS option that you get at AWS. You can get anywhere up to 32,000 or 40,000 IOPS, depending upon the kind of database server that you are using. Dev and test workloads. When you're working with dev and test workloads, performance is not super critical. So one way in which you can optimize your cost on dev and test workloads is by leveraging, containers or Docker. So you can achieve high levels of virtualization to allocate fractions of cores to your dev and test environment. This isn't a new strategy. Customers have been doing similar for ages, with LPAR on AIX or with Zones on Solaris. Hardware modernization with AWS. So my colleague Krish mentioned about how AWS instances run on the latest platforms, and the good thing is with time, as we launch new instances, they all come with better hardware that gives a lot better performance at a much cheaper price point. You also get to leverage, cost-effective SSD storage that comes with, high IOPS at low latency. So if you're running, databases on older hardware in your data center, one good way in which you can increase your performance at a cheaper price point is by moving some of those databases to the latest platform on AWS. You immediately benefit from a powerful platform that provides faster storage. And of course, once it's there on AWS, you can further optimize it by leveraging features like EC2 optimize CPU that I spoke about in a bit. Open source databases, one size fits all or one database for all sort of workloads, isn't an approach that we recommend. So open source databases are very popular today. MySQL, MariaDB, PostgreSQL, they're all battle tested, handle internet scale workloads. However, there's one point where customers tend to shy away from using open source databases. That's support, and that's where Amazon Aurora is really useful. You get to benefit from the best of both worlds. So you benefit from speed and reliability of high-end commercial databases on one end, to simplicity and cost effectiveness of open source databases. It's compatible with MySQL as well as PostgreSQL. Pricing model is fairly simple, pay as you go, and it's delivered as a managed service, which means you don't have to worry about replication, you don't have to worry about taking backups. Everything gets taken, the undifferentiated heavy lifting that Krish spoke about gets taken care of by AWS. Amazon Aurora is, actually a database which has been engineered for the cloud. Under the hood, it leverages shared storage. It's integrated with other AWS services for control plane operations and leverages Amazon S3 for continuous backup. S3 again a battle tested service, highly durable, designed for 11 nines of durability, and provides a number of features in terms of high performance, ease of use, high availability, and security. It's been found to give 5 times the throughput of MySQL. We have a detailed paper around the test bed, which is available on our public site. Easy to operate, easy to provision, easy to patch, highly available. You can use up to 15 read replicas, and it's secure by design. You get encryption at rest using our key management service, encryption in transit, and it uses VPC by default. I wanted to specifically call out one specific feature of Aurora. When I say you get up to 15 read replicas, you can also leverage cross-region replicas for faster or cross-region DR and enhanced data locality. So you can have your master running in one region, and you can have read replicas across different regions. So that way, users local to a specific region can access that particular read replica. And in case of any failover, you can promote one of these replicas in different region to be your master. Aurora happens to be the fastest growing service in AWS history, used by 2/3 of the top 100 AWS customers. These are some of our customers who are using Aurora. I'll take just one example of Expedia, which is world's leading online travel company with a portfolio that includes more than 150 travel sites across 70 countries. So these are some of the metrics that have been shared with us. With Aurora, they're able to attain 25,000 inserts per second with a peak of 70,000 inserts per second, 30 millisecond average response time for write, and 17 millisecond for read. And using Aurora or migrating to Aurora is very easy. So if we talk about migration from a MySQL to Aurora MySQL, if you are using RDS, if your source database is in RDS, then it's one-click snapshot migration that you can use. If you have a non-RDS MySQL database, that is, if your database server is either running on EC2 or is running in your data center, you can use the native MySQL migration tool. So you can take a MySQL dump and import it into Aurora, or you can use tools like Percona Extra Backup, where you take backups to S3 and then you restore it from S3. In addition to these, we also have a service, AWS Database Migration Service, which simplifies migration of databases. Very easy to work with. The best part is it supports both heterogeneous as well as homogeneous migration, which means you can do a MySQL to MySQL, or you can do an Oracle to MySQL kind of a migration. The way it runs, so let's say you have your source database in your own premises, in your own data center, and you want to migrate it to AWS. So you start with a replication instance as part of your VPC in AWS. You connect the source database and the target database. You simply provide the connection string here. You specify the table, the schema, the databases that you want to migrate, and then AWS Database Migration Service kicks in. It takes care of creating the tables, the schema, loads the data, and keeps them in sync. And once it's in sync, you can simply cut over to your database, which now resides in AWS, and change the connection string in your application so that now the new database becomes your source database. I mentioned with database migration service, you can do heterogeneous migration as well. So we provide a tool, AWS Schema Conversion tool, that helps you convert schemas of one database flavor to the other. And when we talk about different database flavors, not only can you migrate data, it also helps you migrate stored procedure. So it does that on a best effort basis, and for stored procedures that it cannot automatically migrate, it provides hints around manual edits that are needed. So over here, if you see, there is a screenshot where it specifically flags off what are the procedures that it failed to automatically convert, and where is it that manual edits are needed. All right, so to summarize, these are some of the ways, I spoke about using which you can optimize your database costs. Use EC2 optimize a CPU to specify the active number of vCPUs in your instance. That way you bring down the license costs directly. Reassess your database edition that you're using. Do you really require enterprise edition features for some of the workloads? If not, then either move to standard edition, use functionalities like adding caching tier in your application architecture to benefit from high performance. For dev and test workloads, we recommend using containers. If you by moving your databases that are running on older hardware to systems to the latest instances on AWS, you directly benefit from high performance at a cheaper price point. And lastly, you can always migrate databases to Amazon Aurora, which is compatible with both MySQL and PostgreSQL. That way, you get to benefit from the best of both worlds, benefit from the performance of high-end commercial databases, at the same time ease of use, simplicity, and cost effectiveness of open source databases. That's all I wanted to talk about. If you have many questions, do send in the chat window. We will try to answer as many as we can. And you can drop a mail at the email ID that you see on the screen as well. And Krish will try to answer as many questions as we can. So let me have a look at some of the questions. So one question is what will happen if I set CPU core as 4 and set threads as 4 as well for R4 4x large instance? Well, that's not a valid core thread value. So if you remember in one of the slides, I had shown the valid values for a particular instance type. The valid number of threads that you can specify for R4 4x large is either 1 or 2. 2 is the default one, so you can only specify 1. You cannot specify more than that. That's because R4 4x large in itself uses Intel Xeon, which provides 2 hyperthreads. Any plans to support IBM DB2 as RDS? So we regularly share roadmap updates as part of AWS, what's new, and AWS various blogs and all. So what I would suggest is keep a tab on those web resources, and that's where we can specify what all databases are currently supported and what all databases that we intend to support. All right. There are no more questions right now, but feel free to send your questions to Krish at kkrish@amazon.com, and we'll get back to you. Thank you for your time. Hope you found the webinar useful. Thank you.